So this is showing the conventional perspective. What was the kind of the traditional model of early in the universe, the death of the first stars, which were massive, produced relatively small black holes, and that these merged and grew via accretion and merging to form the billion solar mass supermassive black holes that we observe today. But this model is just not comporting with observation. And so the conventional model is now becoming much more that you have direct collapse into black holes of these large gas clouds in the early universe. And so instead of your seeds being approximately 100 solar mass black holes, they're on the order of 1,000 to tens of thousands of solar masses. And this matches much better recent observation of the ubiquity of supermassive black holes that they're found in almost every galaxy, and some of these colossal sizes of millions to billions of solar masses. And what's more, though, this is the direct gravitational collapse model, but it should also be recognized that the black holes, primordial black holes, could have formed directly from the Planck energy density at like the earliest periods following the Big Bang, from like the Planck time to even just 1 second after the Big Bang. So your kind of traditional model of many small mass black holes, relatively small mass black holes, forming in the early universe, accreting together. And now the more precise perspective of direct collapse, forming these supermassive black holes. So recent research updated from direct observation of black holes at the centers of galaxies and active galactic nuclei are causing a revision to the conception of black holes. And we see that they are the first objects to form in the early universe and act as seeds to the formation of structure and organized matter, and continue to guide the evolution and development of galaxies and galactic structures. That is, they are galactic engines. This is just exciting developments for us at the Resonant Science Foundation, because this has been one of our key postulates for a long time now. And observation is coming to verify many of the models that we've been describing for 20 plus years. So the first stars that formed and became today's extant supermassive black holes were unimaginably enormous. Now, this is a highly salient new theory, because just as Nassim had predicted that black holes would be found at the center of nearly every galaxy, acting as the organizational nucleus for galactic systems, and that was at a time when the idea was considered somewhat crazy, a black hole at the center of every galaxy, but has now been verified. He's also posited that lower mass black holes could function in a fractally similar way to form the organizational nucleus for stars. Again, at the present time, this idea may seem somewhat ludicrous to the conventional astrophysicists. Yet already, this idea is being applied to explain the observation of supermassive black holes. And that is via the idea of the quasi-star. A star with a black hole at its center. So it's becoming part of kind of conventional theory that the first stars, in fact, had a black hole at their center. It's posited that the first stars grew from primordial or intrinsic black holes. These quasi-stars, as they are called, were not powered by thermonuclear fusion alone, although that could have been occurring. But so within convention, since they're not following that normal model for what a star is, where it's shining because of thermonuclear fusion, that they're not called real stars. They're called quasi-stars. They look and behave like stars, but because they have a black hole at their center, they're not real stars. So that idea will probably need some revision as time goes on. But the astrophysicists are coming to the understanding of the organizational structure of stars, which are following a fractal pattern that you can see as at the same organizational parameters for galaxies, with a supermassive black hole at the center acting as the organizational nucleus. So these quasi-stars, as they're called, eventually grew to truly massive proportions, and so they're visible today across billions of parsecs of space-time as quasars. Again, quasi-stellar objects, things that look like stars but are not stars. Quasars are the beacons at the dawn of time that shine with the strength of billions of stars, and which are generally referred to as active galactic nuclei. AGN is the acronym. So currently, the best way to account for supermassive black holes at the center of most every galaxy, which defies previous conventional understanding of how black holes form and grow, is to posit that the first stars to form had primordial black holes at their center. These would eventually grow to become today's extant supermassive black holes. However, this process is still not entirely understood by conventional astrophysics, and still largely neglects that in the high energy density of the early universe, black holes were formed across a range of sizes and masses, what I like to call intrinsic black holes, which are more commonly referred to as primordial black holes. So